All right, so like I said, page 588 today, and we are going to talk about the law of sines. And theorem 810, law of sines, states that if triangle ABC has lengths lowercase a, lowercase b, lowercase c, representing the lengths of the sides. Opposite the angles, capital A, capital B, capital C. Then here's the rule. The sine of angle A over side A is equal to the sine of angle B over side B, which is equal to the sine of angle C over lowercase c. So all this is an extended proportion. And the picture looks like this. If we take a triangle and label its vertices ABC, then like the rule said, the sides opposite are lowercase a, because side BC is opposite of angle A. Since side AC is opposite of angle B, this is a lowercase b. And side AB is opposite of side angle C, so it's lowercase c. Another way of saying this is the sine of an angle over its opposite side is equal to the sine of another angle over its opposite side. Sine of an angle, sine of B over B equals sine of C over C. The sine of angle A over side A equals the sine of angle C over side C. All right, sine of an angle over its opposite side equals sine of an angle over its opposite side. So here's how you're going to use this today to find side lengths, and maybe not going to find angle measures till tomorrow. So let's look at example 1. We're going to find x. And we've got a triangle, ABC. And side AB is the x. Angle A is 97. Angle C is 21 degrees. And side BC is 16. So here's the rule. The sine of an angle over its opposite side is going to be equal to the sine of an angle over its opposite side. So we write a proportion. And our proportion is going to be sine 97 over 16 is equal to sine 21 over x. So now we've been doing proportions for a while, so we're going to crisscross multiply. So sine 97 times x is sine 97 x is equal to 16 times sine 21. So now, keep in mind, our next step here is going to be to divide both sides by sine 97. Make sure that when you take 16 times sine 21, that you either put it in parentheses or you hit the equal sign after that operation. And then hit divided by sine 97. Okay? So everybody set your calculator. Let's set it to second, fix 1. So we're going to round to the nearest tenth, because that's what the question asked to do. So 16 times 21 sine and hit equals. And then divided by 97 sine and hit equals again. And everybody should get x equals 5.8. All right, and it's real important that you do the calculations with me during the notes and make sure we're all getting the same answers, so that when you're doing the calculations on your quiz on Friday, you're getting the same answers. Everybody get a 5.8? All right, so look at the bottom of 588. Guided practice 1A. Let's do that smaller triangle down there. We got triangle ABC. Angle A is 78 degrees and angle B is 60 degrees. Side AC is X and side BC is 8. So if I do sine 60, what does it go over? X. And it's equal to sine 78 over the 8. So we're going to crisscross multiply again. X times sine 78 is sine 78. X is equal to sine 60 times 8. And I'm going to put it in parentheses. Going to divide both sides by sine 78. The X is going to fall down. So again, 60 sine divided by 8 equals, no, it's not divided, it's times. 60 sine times 8 equals, divided by 78 sine equals, and I got 7.1. Now, right above your answer in the calculator, if you're not getting 7.1, then look right above the 7.1 or whatever number you're getting. Make sure it says DEG. If it says RAD or anything other than DEG, then we're not going to be getting the same answers. DEG is an abbreviation for degree mode for the calculator. If it's in a different mode, we won't be getting the same answers. Any questions so far? Look at the top of page 589. Those are all the same type problems, aren't they? All right, so let's do one more example. Let's do example 2. So we got HJK. Angle H is 45 degrees. Angle J is 73 degrees. Side KJ is the X, and side HJ is the 10. Now look, if we do sine of H over X, agreed? We know an angle and we know its opposite side. So sine 45 over X equals, if we use sine of 73, we don't know its opposite side, do we? But if we know two angles inside of a triangle, can't we find the third angle? Doesn't K, or I'm sorry, the measure of angle K equal 180 minus 45 minus 73? So make sure you find that angle measure first. $62 degrees. All right, so now we know that angle K is 62 degrees. So we can do sine of angle K over its opposite side. So sine 62 over 10. The angle and its opposite side is what you're always working with. You can't just take an angle and any other side. It's sine of an angle over its opposite side equals sine of an angle over its opposite side. So our sine 62x is equal to sine 45 times 10. Gonna divide both sides by sine 62. And our x is equal to Everybody get 8? All right. Any questions? All right, practice for today. Page 592. One through 4. And then 12 through 20. Read the directions, please. Follow the directions. Find x, round angle, measure to the nearest degree, and side measure to the nearest length. All right. Angle measures to the nearest degree, side measures to the nearest length.